Welcome to the DIY Honda Garage channel. The DTC P16F6 indicates an issue with the starter cut relay 2 control circuit, categorized as a high voltage fault. This diagnostic trouble code, DTC, is specifically tied to the powertrain control module, PCM, within the Honda Civic models from 2016 to 2021. The starter cut relay plays a crucial role in ensuring that the starter motor engages only under appropriate conditions to prevent unauthorized starts. High voltage in this context means that the relay control circuit is receiving voltage levels beyond its specified operating range, which can cause components to function improperly or even risk damage. Identifying this fault typically involves analysis through the Honda Diagnostic System, HDS, for proper verification of the issue. Repair and replacement actions may hinge on the confirmation of this DTC, focusing on the relay circuit board, wiring, and the PCM itself. The DTC P15F6 pertains to the starter cut relay 2 control circuit exhibiting high voltage. The starter cut relay, often located within a relay circuit board, is responsible for controlling power to the starter motor, ensuring that conditions are safe for engine starts. Typically, this relay is situated near the engine compartment alongside the powertrain control module, PCM, which orchestrates various engine functions. High voltage symptoms indicate that the relay control circuit is receiving excessive voltage, leading to malfunction. This can stem from various causes, including short circuits or wiring issues. Each component's role is vital for the overall performance of the vehicle, and any issues detected will need thorough examination to avoid impairing engine start capabilities. There are several possible causes for the DTC P16F6, starting with a poor connection at the relay circuit or the PCM, which can create intermittent issues leading to high voltage readings. A defective relay circuit board itself is another major cause that can yield a high voltage condition. In addition, shorted wiring, particularly in the starter cut relay 2 control line, may also directly cause this DTC by allowing excess voltage flow. Any of these conditions, if present, can impact the way the starter motor operates and should be examined carefully during the troubleshooting process. Recognizing these causes is essential in isolating the problem effectively. As with any diagnostic procedure, accurate identification of symptoms is crucial to guide the technician in the correct repair path. When dealing with the DTC P16F6, several symptoms often arise that can indicate an underlying problem. Primarily, the vehicle may exhibit difficulty starting, or sometimes it may not start at all, as the starter cut relay manages the initiation of the starter motor. Drivers might also notice a high voltage warning, particularly on the vehicle's diagnostic interface, which indicates an unsafe electrical condition. Additionally, pending diagnostic trouble codes may appear in conjunction with P16F6, suggesting that further investigation is necessary. If symptoms are present, but the DTC does not remain confirmed, this could imply an intermittent issue. Recognizing these signs early can lead to a faster resolution of the underlying electrical faults to ensure proper vehicle operation. The first step in addressing DTC P16F6 involves initial problem verification. Begin by turning the vehicle to the on mode, which activates the electrical systems without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs from the engine control unit. This step is critical, as it allows for the testing environment to be reset and any new trouble codes to be captured without confusion from previous fault records. After clearing the DTCs, start the engine to assess if the same or new DTCs appear. This procedure helps isolate the issue directly related to the starting system. If the DTC remains present, you confirm that the problem is indeed real and replicable, thus warranting further investigation. The second step entails a thorough examination of the relay circuit board. First, turn the vehicle off or to the lock mode to ensure safety and avoid any electrical hazards. After the vehicle is powered down, carefully remove the relay circuit board to access the internal components. Inspect the board meticulously for signs of physical damage, burnt connections, or corrosion, which could affect its functionality. Testing the circuit board involves using a multimeter to measure continuity and voltage across the necessary terminals. If the relay circuit board is found to be functional, you can proceed to the next diagnostic step. However, if it fails to meet specifications, replacing the circuit board is necessary to resolve the high voltage issue indicated by DTC P16F6. Troubleshooting step 3 involves checking for a shorted wire that may be causing the high voltage problem. First, jump the SCS, Service Check Signal line, using the Honda Diagnostic System to enter the diagnostic mode. After waiting more than a minute to allow the system to stabilize, proceed to disconnect the PCM connector A, which has 50 pins. This step is vital as it isolates the system and removes the PCM from the equation, preventing misleading measurements. With the vehicle turned on, measure the voltage at designated test points. Specifically, you will measure between PCM connector A, pin number 23, and body ground. If the measured voltage is 0.1 volts or less, the wiring is intact, indicating no shorts to ground. In this case, check for additional service information or consider replacing the PCM. Conversely, if you detect a higher voltage, it is essential to repair any short circuit between the PCM and relay circuit board. After any repairs related to DTC P16F6, conducting a final verification is crucial. Start by clearing DTCs once more using the HDS to ensure the system is reset and any previous errors are eradicated. Next, run a comprehensive engine test to allow the vehicle's systems to engage fully and observe real-time operation under various conditions. This is essential to ensure that the repairs made have resolved the underlying issue. Post-testing, recheck for any confirmed or pending DTCs. The absence of DTC P16F6 would indicate a successful repair. Should the DTC reoccur, further investigation into potential secondary issues or deeper electrical faults may be required. Ensuring verification is a crucial part of the diagnostic and repair process, providing peace of mind that the vehicle is functioning optimally. To prevent future occurrences of DTC P16F6, engaging in preventive maintenance is highly recommended. Regularly inspect all electrical connections related to the starter cut relay and PCM, as loose or corroded connections are common culprits for electrical failures. Maintaining clear and secure connections helps ensure that the vehicle systems work reliably. Additionally, it is essential to monitor the functionality of the relay circuit and other associated components to catch signs of wear early. Carrying out regular updates to the PCM when necessary can also enhance overall vehicle performance, ensuring the unit operates with the latest software adjustments and fixes. Keeping these checks in mind will significantly reduce the likelihood of encountering high voltage faults again in the future. In summary, understanding DTC P16F6 is imperative for maintaining the starter system within the Honda Civic models from 2016 to 2021. A thorough troubleshooting process, as detailed across the preceding slides, involves verification through the HDS, checking relay function, and ensuring wiring integrity. Each step addresses potential sources of the high voltage issue, providing clarity on how to approach repairs effectively. Additional emphasis on preventive maintenance can mitigate the risks of future failures, particularly concerning electrical connections and relay performance. By following these guidelines, technicians can enhance the reliability and safety of the vehicle, ensuring it performs optimally for drivers. Please like and subscribe to the channel. See you next time.